We have 7/8. So we have joined all the parts together. Can we count? How many parts do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 eighths. And this can be written as 8 all over 8, where the numerator, which is 8, is the 8 parts we have that is to be considered, and the denominator is 8, which is the total number of parts that we have. So 8 over 8 gives us our whole bag. What is the denominator of 3 over 4? What is the denominator of 3 over 4? A says 3, B says 4, and C said 7. Remember, we said this is our fraction bar, and the number above the fraction bar is called a numerator, okay? And the number that is below the fraction bar is our denominator. And the question is asking us the denominator of 3 over 4. So since we said the denominator is below the fraction bar, which of these options is right? We can see that the number that we have below the fraction bar is 4. So that means that our denominator for the fraction 3 over 4 is 4, and that is option B. We have another question, and it reads, what fraction has 4 in the numerator? What fraction has 4 in the numerator? Again, like I explained earlier, we have our fraction bar, and the number that is above the fraction bar is our numerator, and the number that is below the fraction bar is our denominator. And the question wants us to find what? The fraction that has 4 in the numerator. Now let's look at the options. Option A reads 1 over 4. Option B, 4 over 5. And option C, 1 over 3. So what fraction has 4 in the numerator? Again, the numerator, we said, is the number that is above the fraction bar. Now this is the fraction bar for each of the options. Which one has 4 as the numerator? In option A, we can see that the numerator is having what number? It's having 1. So obviously it is not 4, and it is out. How about option B? In option B, what is the number that is above the fraction bar? The number above the fraction bar is 4. And that is exactly what we are looking for. We are looking for a fraction that has 4 in the numerator. option B is the right answer. Does this show 5/6? Does this show 5/6? Yes or no? Yes or no? Okay, what do we have here? We have a chart. And this chart is divided into how many equal parts? Can we confirm? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The chart is divided into 11 equal parts. But if you look at the chart, you can realize that some parts of the chart is colored. Some parts of the chart are colored. And the color is red. Now, what do we want to know? We want to know how many parts are colored in red. We want to know how many parts are colored in red. Can we count together? 1, 2, 3, 4, 5. 5 parts of the chart are colored in red. Now, if we want to represent parts of the chart that are colored in red, we are going to represent it as the number of red, the parts that are colored in red all over the total parts in the chart. And that is going to be 5 over the total number of parts that we have is 11. And I repeat, 5 is the parts that are colored in red, which is the numerator, and the denominator is the total number of what? Parts that are in the chart, and that is 11. So now, let's go back to the question, which reads, does this show 5/6? Look at what we have. We have 5/11. Is 5/11 equals to 5/6? Is this equals to 5/6? No. The answer is no. So we circle no, because the chart that we have is showing 5/11. What fraction of the whole is shaded? What fraction of the whole is shaded? We have a chart, and parts of the chart are colored. Okay? So, but first, can we count the total number of parts that we have in the chart? Yes, can we count together? 1, 2, 3, 4, 5, 6, 7, 8. We have 8. So we have 8 equal parts in our chart. Okay? But if you look at the chart closely, you can observe that some parts are colored, and they are colored in yellow. Okay? Those are the shaded part. So the shaded part is in what? In yellow. Okay? So can we count these shaded parts in our chart? We have what? 1, 2, 3. 3 parts are shaded out of the 8 parts that we have. So out of the 8 parts, 3 parts are shaded. Now, let's go back to the question. And it says, what fraction of the whole is shaded? Already, we have confirmed that 3 parts of our whole is shaded. So we have 3, and we bring our fraction back. So 3 over what? 3 over our total parts, which is what? 8. So the fraction of the whole which is shaded is 3/8. 3/8, that is 3 over 8 is shaded. What fraction could this picture show? What fraction could this picture show? Let's look at the picture. What can we see? We can see an orange being divided into 2 equal parts. This is one part, and this is another part. And if you look at the picture again, one part of the orange, which is 1/2 of the orange, is in a box. If we are to represent this as a fraction, it is going to be 1 over 2, because we have 2 halves. So it's going to be 1 over 2. 1 is the half that is in the box, over, that is divided by the 2 halves. So we have 1 over 2, which is a half. Okay? But again, if you closely look at the picture, you will realize that each half is further divided into how many parts? It is further divided into parts. Can we count how many parts? Let's look at the first half. How many parts is it divided into? Let's count together. 1, 2, 3, 4. How about the other half? How many parts is it divided into? Can we count again? 1, 2, 3, 4. So we have 4 parts. So each half is divided into how many parts? 4 parts. Now what is the total number of parts, the equal parts that we have? It is going to be the 2 halves put together and the parts that they are divided into. Can we count? 1, 2, 3, 4, 5, 6, 7, 8. So the 2 halves are further divided into 8 equal parts. Okay? Again, if you look at the half that is in the box, it is divided into how many parts? We said 4 parts. That is 1, 2, 3, 4. So it's going to be 4 all over. What is the total number of parts that we have? It is 8. That is the 2 halves. If you put the parts together, it is going to give us 8 parts. Can we confirm that? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 4 over 8. So this picture is showing us 2 fractions. One is half, and the other one is 4 over 8. That is 4 eighths. Okay? Now let's look at the option. Option A is half. Option B is 4 over 8, which is 4 eighths. Option D is both A and B. And option D is neither A nor B. But we have half and 4 eighths, which means option what? Option option C is right. That is both A and B. That is what the picture is showing us, which is half and 4 over 8, which is 4 eighths. Which diagram could be used to show 1/5? Which diagram could be used to show 1/5? We have option A, B, C, and D. Each option is having a diagram, and we want to know which one could be used to represent also 1/5. Now, let's start with option A. For option A, let's look at the diagram. How many parts is the diagram divided into? How many parts? Can we count? 1, 2, 3. The diagram is divided into 3 equal parts. Now each part is what? 1/3. And that is written as 1/3. Now we move on to option B. For option B, let's look at the diagram. How many parts is the diagram divided into? How many equal parts? Let's count. 1, 2, 3, 4, 5, 6, 7. It is divided into 7 equal parts. Now, how are we going to represent one part of this diagram? It is going to be written as 1/7. 1 is just one part, and 7 is the total number of parts that the diagram is divided into. So it's divided into 7, so we have 1/7, which is 1/7. Let's move on to C. For option C, let's look at the diagram. It is divided into how many parts? It is divided into 2 parts. Can we confirm by counting? 1, 2. Now, each part can be written as 1/2, which is a half, right? It's just a half. Now let's look at option D. For option D, the diagram is divided into how many parts? Let's count. 1, 2, 3, 4, 5. The diagram is divided into 5 equal parts. Now each part can be written as 1 over 5, which is 1/5. Now let's go back to our question, which says, which diagram could be used to show 1/5? If you look at option A, is showing 1/3, which is not what we are looking for, so it's out. How about option B? It is showing us 1/5. No, it is showing us what? 1/7. So automatically option B is out. How about option C? It's showing us half. Is that what we are looking for? No. C is out. Now how about D? D is showing us 1/5. And that is exactly what we are looking for. So our right option is option D. Okay, let's move on to the next slide. We have another question, and the question reads, which three shapes have parts that are 1/8 the area of their whole shape? I will read again. Which three shapes have parts that are 1/8 the area of their whole shape? Now we have option here, A to E. Now let's look at option A. In option A, we have a hole. Are all the parts equal? Yes, all the parts are equal. How many parts are there? Can we count together? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 parts in this whole, 9 equal parts. The whole is divided into 9 equal parts. Now each part can be written as 1 all over 9. We move on to the next option, which is option B. In option B, we have a whole. Are all the parts equal? Yes, all the parts are equal. How many parts do we have? Can we count? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 equal parts. Each part can be written as 1 over 8, where 1 is referring to one part and the 8 is referring to the total number of parts that we have in the whole. Now let's move on to C. Let's look at this. Let's look at the whole. We have a whole. Are all the parts equal? Yes, all the parts are equal. How many parts are there? Can we count together? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 equal parts. That is, the whole is divided into 8 equal parts. Now one whole, one part can be written as 1 all over the total number of parts in the whole is 8. Now let's move on to option D. In option D, we have a whole. Are all the parts equal? Yes, all the parts are equal. How many parts do we have? How many parts do we have? That is, the whole is divided into how many parts? Can we count? 1, 2, 3, 4, 5, 6, 7, 8. The whole is divided into 8 equal parts. Now, one part can be written as 1 over the total number of parts that we have in the whole is what? 8. We move on to option E. In option E, we have a whole. Are all the parts equal? Let's look at it. No, the parts are not equal. So, option E is automatically out because the parts are not equal. So it says what? Drag and drop the correct 3 shapes into the box. So we have a box here. And from option A to option E, which ones are the correct shapes? Can we refer back to our shapes? Option A, remember, we are looking for what? Shapes that have one, 8. Remember, that's what we are looking for. Option A is 1/9, which is not 1/8. So option A is out. How about option B? In option B, we have what? 1/8. And that's exactly what we are looking for. So we have to drag and so we bring it down. So we have it here. How about option C? Option C is also what? 1/8. So we also drag this shape into the box. How about option D? Yes, option B is also 1/8, and that's exactly what we are looking for. So we'll drag the shape into the box. So all the shapes that shows 1/8 are in the box. Okay. We have an exercise. Exercise 1, the instruction reads, circle the numerators in these fractions. Circle the numerators in these fractions. A, we have 7/8. A, 7/8. B, 2/3. B, 2/3. C, 6/12. C, 6/12. D, 9/10. D, 9 over 10. So what we need to do here, just circle the numerators in these fractions. Okay, I assume you are ready. So let's start. Let's start with A. A is 7 over 8. 7 over 8. And we said we are asked to do what? To circle what? The numerators. And we have said that the number above the fraction bar is what? The numerator. Now if you look at A, this is our fraction bar. And the number above the fraction bar is what? 7. So 7 is our numerator in A. So we circle 7. We move on to B. B is 2 over 3. 2 over 3. Again, the number above the fraction bar is the numerator. In this case, which number is above the fraction bar? It is number 2. So 2 is our numerator in B. How about C? C, we have 6 over 12. 6 over 12. And the number above the fraction bar is which number? 6. 6 is above the fraction bar. So 6 is our numerator in option in C. We move on to D. In question D, we have what? 9 over 10. And again, the number above the fraction bar is 9. So 9 automatically becomes our numerator for D. I hope you all got that. Now let's move on to exercise 2. It says circle the denominators of these fractions. Circle the denominators of these fractions. A reads 5 over 8. A reads 5 over 8. B 1 over 2. B 1 over 2. C 2 over 6. C 2 over 6. D 8 over 12. D 8 over 12. What do we need to do here? We need to what? Circle the denominators. So try that. Circle all the denominators in these fractions. Let's carry on. A is 5 over 8. 5 over 8. And we have said that the number below the fraction bar is the denominator. The number below the fraction bar is the denominator. Now in A, which number is below the fraction bar? Is 8. 8 is below the fraction bar, so 8 is the denominator for A. 8 is the denominator for A. Let's move on to B. B, we have what? 1 over 2. 1 over 2. Which which number is below the fraction bar? Which number is below the fraction bar? The number below the fraction bar is number what? Number 2. So 2 is the denominator for B. We move on to C. C is what? 2 over 6. 2 over 6. And the number below the fraction bar is our denominator. In this case, which number is below the fraction bar? It is number 6. So 6, we circle 6. 6 is our denominator for C. Now let's move on to D. D says what? 8 over 12. 8 over 12. Which number is below the fraction bar? The number below the fraction bar for D is what? 12. So 12 is the denominator for D. Okay. That is all that we have for you, viewers and listeners, for our lesson today, and we hope you have learned a lot. Before I leave, I just want to remind you all that please let's follow the advices from our health workers. That is, always wash your hands with clean water and soap. Avoid crowds, that is, avoid public gathering. Also exercise or maintain what? Maintain social distancing. Please stay at home to protect yourself, your family, and your loved ones. On that note, I thank you all. Hope to see you again.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Who's the winner now?
We don't have a winner. The scores are too similar.
Look, Kibena and Koba both got 8. Baraka has 5 and me, I have 6. We need another round of jumping rope to get a winner.
The winner's just arrived. There's no need for another round, guys. Just let me jump and I'll beat you all.
1, 2, 3, 4, 5, 6, 7, 8.
21, 22, 23, 24, 25, 26!
Well, there you go. You've gotten your champion, me. How many did I jump again?
26!
I am the champion, I am the champion is me. I'm Super Monkey, woo-hoo.
That monkey! He thinks he's so good! What a jerk! Look, guys. Gadara beat each one of us. Better if we compete against him as a team. He said he can beat all of us. But look at our points. Our total points. If you add them up, we can beat him.
That's right.
8 plus 5
Is 13.
13 plus 6
Is 19.
19 plus 8
Is 27. And Gedere only got 26. So together we can beat him.
Kibena and Koba, you each jumped 8 times. So if the two of you jump together 8 times each, you'll get a total of 16. What? What are you talking about? There are 2 of them. So if they jump together 8 times, that's 2 times 8. It's 2 8 times. That's all 2 times 8 means.
Oh, I get it. So if you take 2 times 8, you get 16.
But with that, we still can't beat him.
All right, I have a plan. We all need to jump together and then we can win. But who'll hold the rope for us?
Let me call some friends to hold the jump rope for us.
We heard you call us, Kibena. How can we help you?
Thank you for coming, you guys. You're such good friends, always willing to help out. Would you be willing to help us out by holding the jump rope? We want to compete again with Ngedere.
Ngedere?
Ngedere beat us each individually. Look, he's still celebrating over there. But if you hold the rope while the 4 of us jump, we can win this time around.
No problem. We got this.
Ngedere! You Ngedere!
Huh? What's going on?
Ngedere!
Another round? You can't beat me, my friends. You wanna lose again? Okay. Suit yourself.
All right, Ngedere, you start this time.
1, 2, 3, 4, 5, 6, 7,
22, 23, 24, 25.
26, 27, 28.
I'm the champion!
Hey, Gadara, remember how you said you could beat all of us? Look now, we're all going to jump together, and we're gonna beat you.
1, 2, 3, 4, 5, 6, 7.
You've lost yet again. You've only got 7.
Patience, Ngedere. We have to calculate the scores before you can start celebrating.
There are 4 of us, and each one of us has jumped 7 times. So in total, we have jumped 4 times 7 times. What is that?
4 times 7? How should I know?
4 times 7 means plus 4 is 8. And then you keep adding. 12, 16, 20, 24, 28.
28! Word said we can get there.
Woo! You tricky kids. You use math to win, huh? Wow! That's impressive. Okay, you're smarter than me.
Now it's our turn to jump rope. Who will count for the elephants?
Let's all count.
1. Aya! Oh, Daddy, we got 0.
But there are 2 of you. So that's 2 times 0. Hey, Kibena, how much is that?
Ngedere, anything times 0 is just 0 because there's nothing. So 2 times 0 is 0.
Don't you guys remember the song?
Which song?
What does 0 mean? We already knew it.
Sing it again.
What does 0 mean?
It's
just a number that means nothing.
Uh-huh. We missed because we want to teach you the meaning of 0 in multiplication. I think now you understand. We could jump until morning if you wanted to.
What does 0 mean?
It's just a number that means nothing.
What does 0 mean?
It's just a symbol that means nothing. Negative is a number that is less than 0. Negative is a number that is less than 0.
What does 0 mean?
It's just a number that means nothing.
What does 0 mean?
It's just a number that means nothing. Negative is a number that is less than 0. Negative is a number that is less than 0.
What does 0 mean?
It's nothing.
What does 0 mean?
I said it's nothing.
I said, what's negative mean?
It's less than 0.
What's negative mean?
Less than 0.
What does 0 mean? Okay, what does 0 mean?
I said it already.
What's negative mean?
I already told you.
Negative mean? What does 0 mean?
Why don't you understand?
What does 0 mean? What's negative mean? What?
The negative is less than 0.
Okay.
0 means nothing. Why don't you understand?
Okay, I get it now.
I already
I got
told
it.
you.
Okay.
It's about
Okay, I get it
time.
now, I get
Why
it.
don't you understand? Finally.
Negative is a number that is less than 0. Negative is a number that is less than 0.
Hey! Do you want to see more great videos from Ubongo Kids? Visit our YouTube channel, Ubongo Kids English, and you'll see lots of special clips, behind-the-scene videos, and tips on how to be a real Ubongo Kid. Just go to YouTube and search Ubongo Kids English, and we'll see you online.
Hi, I'm Melody, and I act the voice of Tiny Temple. Do you believe me or not? So please listen and watch. I love smiling, I love math, and I love talking to other children. So please keep on watching Ubongo Kids. These are the Ubongo animators, and they're the people that take our voices into the cartoons. Hi, Rajab.
Hi Melody, how are you?
Fine. So Rajab, can you please show us how you take our voices and make them animate them and put them into the cartoon, please?
Okay. First of all, we start with the script. After the script has been developed, is whereby we prepare the storyboards This story was just like the sketches. Maybe we can tell if right now, like example, this one, Mzee Kigo here is digging the farm, which give the animators to know exactly which shots to animate and the audio, how it goes. So after we prepare the storyboard is when we scan it and take the audio from the studio so that we can mix them together using a software. After we have mixed them together, we prepare the so-called animatic. After we have done the animatic, it's like we mix the audio with the sketches. Then each animator is given like this, something like this, like the animatic. Then after that is when we start to animate.
Okay, thank you.
Yeah.
So how long do you think it takes to make one story?
One story takes like from about 2 weeks to 3 weeks. Yeah.
How are you, Dad?
I'm fine, Kiduchu. Why are you back so late?
I've had a crazy day. We played football and learned math.
You've been learning maths? Nice, Kiduchu. But what did you learn?
Positive and negative numbers.
Such as?
-3 plus 2 is -1.
Ah, and what if I asked you -3 times -2?
Oh, come on, Dad. I'm tired. Let's watch TV.
Okay. If you're so tired, why don't you go to your room and rest?
I'm watching the soldiers. Don't you know I want to be a soldier someday?
Being a soldier's hard work. All sweat and tears. You really think you could do it? All those boot camp workouts. Could you take it?
I can do it, Dad. Let me show you. To the left and turn. To the back and turn. See? I can do it.
You think the soldiers get to direct their own parade? Someone else gives them instructions, then they have to follow. Can you follow instructions?
Of course I can.
Okay then, listen carefully now. I'm going to instruct you on a very special parade called the multiplication parade. 2 steps forward, march. 2 more steps forward, march. For the last time now. 2 steps forward, march. You've done well, Kiduchu. Hey, tell me now, how many total steps have you walked?
2, 6 in total.
Okay. We can sum that up by saying 2 steps times 2. 2 steps times 2. Do you understand? 1, 2, pa, pa. 1, 2, pa, pa. 1, 2, pa, pa. In a multiplication parade, there can be both negative and positive numbers. You want me to show you? Don't you want to be a soldier?
I really do, Dad. Show me, show me.
In the multiplication parade of positive and negative numbers, you have to listen to the instructions very carefully. This negative sign shows you to turn. For the first negative sign, you turn to the left. Then you move towards the negative side. And if there's another negative sign, you turn to the other side. Chop! That's the positive direction. Then if there's another negative, you turn again. Chop! You get it? Okay, let's try it out. The first march, -2 times -2. First negative, turn. Second negative, turn. 2 times 2, march. So So what do you think you'll get now?
It's positive 4.
Well done, Kiduchu. You really could be a soldier.
Ah, Dad, I understand. So if it's negative 2 times negative 2 times negative 2, it'll be like this. First negative, second negative, third negative. 2 times 2 times 2.
Okay, so how much is that now?
Negative 8.
Aha! So, negative 2 times negative 2 times negative 2 is negative 8. Well done.
Phew, Dad. I am really tired now. Can I go rest? But I really did like the multiplication parade.
Kiduchu, walk like a soldier. Very nice. Well done, Kiduchu.
But Mama, if you multiply a negative times negative, what do you get? Explain it, Mama.
A negative times a negative.
In Kiswahili, we'd say hasi. That means negative.
For example, negative 3 times negative 4. Let's look at those negatives first. Do you see that? Negative times negative is positive.
That's right. A negative times a negative is positive.
So, 3 times 4 is what, children?
12.
What's that in Kiswahili?
3
And negative times negative is positive. So, negative 3 times negative 4 is positive 12.
That's right. It's positive 12.
So then, what's negative 3 times negative 4 times negative 2?
Use your brains, kids. You can answer that yourselves. Just give it some thoughts and you can do it.
We already know that negative 3 times negative 4 is positive 12. So now, what's positive 12 times negative 2?
Positive times negative is negative.
Positive times negative is negative.
And 12 times 2 is 24. So the answer is negative 24.
So, all together, repeat for me.
Negative 3 times negative 4 times negative 2 is negative 24.
Wonderful! You make me happy.
Well done. Come on. It's time for music.
Hey kids! Kibena needs your help! Help her pick the right number! Aha! That's it! All of you can help Kibena out using an Android smartphone. Download our Math Rats app, which has versions in both English and Kiswahili. Ask a parent or adult to help you. Then go to the Google Play Store and search for Ubongo Kids. Pick the app in the language you want and click Install to download it for free. Open it up and you'll have a fun, new educational app to play anytime you want. Need help? Just visit our Facebook page and we're here to help you out. Download it and we'll see you on the phone.
Mathematics, 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 hey, yeah, yeah. Mathematics, how I love it. Mathematics, hey, yeah, yeah. Sing about the magic of mathematics. Mathematics, hey, yeah, yeah.
is mathematics, mental acrobatics every day, all the time. Just use your mind. You use math when you measure width and length, solving problems using mental strength. Use number operations like multiplication. The number you'll find is like magic from your mind. Math is a part of everyday life. Just add, subtract, divide, and multiply. Can you solve the problem? Did you get the answer? Just use your brain and you can do it, sir. Now, don't you rush it. Just take it slow. You must be careful. Don't you know? You use math for all things in life. When you eat ugali, you count your bites. In a parade, count the steps you take. Just listen when I rap. I'm using math. Calculate the distance when you drive your car, so you will know if you've gone far. Here's something else for you to count. Can you count the teeth in my mouth? We can measure width, length, and depth and represent with X, Y, and Z. Math is used for everything. Just do the numbers in your head. Now try to add up all the spots on my neck. How many do you see? And I even use math to get leaves off the tree.
Mathematics, mathematics, mathematics,
Okay.
Mathematics, how I love it. Mathematics, Sing about the magic of mathematics. Mathematics, Making number magic with mathematics. Mathematics, Sing about the magic of mathematics. Mathematics,
We, the children and staff of Mary's Little Lamb School, are contributing this song to help in the fight and sensitization of coronavirus in the Gambia. Dear children, please listen to doctors' advices and the Ministry of Health to help stop the spread of this virus. Avoid handshakes, avoid social gatherings, wash your hands always with soap and clean water, stay at home, and if anyone around you is suspected of having the virus,